Good morning. This is your stat sensei, Mr. Spence, and this is going to be a warm up. And it's going to be the same thing we've been doing, looking at the empirical rule as it applies to the normal distribution and to the distribution of means or central limit theorem. So, a survey is planned to determine the mean monthly electric bill for residents in a suburban. The average electricity bill is 275 with a standard deviation of 50. Let's go ahead and mark that off to the side. So the mean is 275, and our population standard deviation is 50. Label the mean and standard deviations as well as the z-scores and include the percentages associated with the empirical rule for the electric bills. So let's start off with z-scores. Please remember all z-scores have a mean equal to 0 and a standard deviation equal to 1. And we're starting off with the z-scores because they're the easiest. So here's our mean, 0, 1, 2, 3 standard deviations above. Please remember this goes to positive infinity. We're going to label this z for z-scores. And this goes to -1, -2. And ultimately, it goes all the way to negative infinity. And once again, those are our z-scores. The standard normal, plus or minus 1 standard deviation, is 68%. Plus or minus 2 standard deviations is 95%. And plus or minus 3 standard deviations is 99.7%. Now, please remember this is true for all normal curves, but it's only true for the normal curves, not for other distributions. So while that's the standard normal, in this case, we're working with it should have told us here that this was normal, and I'll fix this. It should have told us this was a normal distribution because it only applies to the normal. So I need to go back and say that this is normal on your assignment. So the mean is 275, and it has a standard deviation of 50. Excuse me there. So if I add 50 to this, I get 325. Add 50 more, I get to 375. Add 50 more, I get up to 425. But technically, this could go on for infinity, some very expensive electric bills. Well, taking away 50, which means I'll have 50 between each one of these, is this becomes 225. This becomes 175. And this becomes 125. So given a random sample of 100 residents, label the mean and standard deviations as well as the z-scores included in the percentages. So let's remind ourselves that our mean here, the mean of the population is 275, and the standard deviation of the population was 50. Now, in this case, we're telling us that we have a sample size of 100, and we're going to go ahead and do some work here in just a moment to talk about the mean and standard deviation, z-scores associated, the sampling distribution of the mean. We're no longer talking about the individual values, we're talking about the mean. So in this case, when it has the mean, they're actually talking about x bar, and we'll come back to that in a moment, or the mu of x bar, the mean of x bar. So first off, we're going to go ahead and do the z-scores. Well, that part we've already done once, so doing it again should be real easy. 0, 2, 1, 1, 2, and 3, all the way to positive infinity. That's a z-score. This is -1, -2, -3, all the way to negative infinity. Once again, plus or minus 1, 68%. Plus or minus 2, 95%. Plus or minus 3, 99.7%. All right. Before we go ahead and do the rest of our graph, let's answer these questions. It says, what's the mean of the sampling distribution for the mean of the electricity bill? Well, the mean of the population we said was 275. Well, I've always said the mean is the mean is the mean. So the mean of the population equals the mean of the X bar, which in this case is 275. So the mean of X bar is $275. Really no work there to be done. Then it says, what's the standard deviation of the sampling distribution? And at this point, we have a little bit of work here because the mean of the sampling distribution equals the standard deviation. The mean of the stand looks like this. The standard deviation of the sampling distribution looks like this. The standard deviation divided by the square root of n. So that's the standard deviation of the population divided by the square root of n. Well, the standard deviation of the population was 50 divided by the square root of 100. Well, the square root of 100 is 10, so 50 divided by 10 is 5. So the standard deviation of X bar is 5. Or in this case, more appropriately, the standard deviation of X bar is $5. So we already know that the mean was 275. And the standard deviation of X bar is 5. So this is going to be 5 between all of these. Well, that makes that 275 plus 5 is 280. Plus 5 more is 285. Plus 5 more is 290. Subtracting 5, we get drop down to 270. And we're going to subtract 5 more from the 270 and drop down to 260. And we'll subtract 5 more from that and end up at 255. All right. That's our warm up. Hope that helps and look forward to seeing you on the next one. Thank you.